In class example 3.13, we will again solve an exponential equation for which both sides can be written as powers using the same base. It might be less obvious than our previous example, but can you recognize the common base for 8 and 1/4? If you can, replace them and see if you can solve the equation on your own before clicking through the steps of the video. Most people will recognize 8 as being 2 cubed, but it might be less obvious that 1/4 is 2 to the negative 2. That's because 2 squared is 4, and 1/4 is the reciprocal of 4, so using a negative exponent achieves that. Now we have to distribute the exponent inside the bracket to the binomial outside the bracket. So 3 times x plus 2 gives us 3x plus 6, and negative 2 times x plus 3 gives us negative 2x minus 6. At this point, we have 2 to a certain power equals 2 to a different power. So those two exponents must be equivalent. So we write that 3x plus 6 must be equivalent to negative 2x minus 6. From here, we solve for x and find that it would be negative 12/5. We can verify this by replacing x in the original equation on both sides with negative 12/5. Evaluating each side independently in our calculator, we find that each one generates a result of 0.435. We could also achieve this by verifying graphically. We would replace y1 with the left side of the equation and y2 with the right side of the equation and find the intersection point. Or, if we subtract the right side of the equation from the left side of the equation, then we would simply graph y2 as being 0, or use second calculate 0. In all of those cases, the x-coordinate we find as a solution would be our answer. As a pro tip, if after calculating an intersection point, you return to the working screen of your calculator by pressing quit, and then press X enter, it will bring that X result over to that screen. If with negative 2.4 you pressed math frac, it would then convert that into fraction form for you.